All right, folks, here we go. Okay, so what we're going to talk about today is arithmetic sequence, arithmetic, right? Arithmetic sequence, arithmetic. Um, and this is kind of like a little bit of like logic puzzles. It's just figuring out with a sequences, especially with arithmetic, with arithmetic here, it's going to be adding or subtracting a value to get to the next term. First term, second term, third term, fourth term. We'll talk about these notations later. But first off, just in the chat, let me know what is going to come next and how did you know? Say what's going to come next and how did you know? What do you think? All right. Well, if we have 3, 12, 21, what is the step to go from there to there? 9. How about from here to here? Yeah, they've increased by 9 each time. So to get to the next term that was missing, we add 9 and we get 30. Boom. Okay. And this one right here. This is just what comes next. What comes next? What comes next is just going to involve taking the term and adding to it to get to the next term, adding the same amount. It's always the same increment. And that is the common difference. The common difference was 9 right here. So this is the common difference. Common difference. And the common difference is going to be D. Okay? The common difference is D. That's the letter we're going to use for it. All right. Now, some of you may have already started because you saw the second half here. What number would be the 23rd term? Whew. Don't try to solve it. I'm going to show you a trick, and that's the second half of this lesson is, nice, Calvin. Well, actually, not quite. Someone else said that last time. This right here is just what comes next. The other type of problem we're going to face is what would be the 23rd term? That's not what comes next. That's like, I know the first term, what's the 23rd term? Okay. So that is the second part of the assignment here. So we're going to come back to these problems as we look through these two different approaches. Okay. So to start, in order to find the next term, right? This is the mental math that we did up here. For these type problems, you can jot some notes on how you get to the next one, but I don't need to see the mental math part, the find the next term. I don't need to see the formula done for every single one of them, okay? Because if we're just adding 9, there's no need to write everything out. Oh, it's 3 plus 9. Oh, it's 12 plus 9. That could be some mental math, guys. And look what we have. We have the next term is just the prior term plus the common difference. Think about that. Going back to our top example, our next term, if I knew A1, A sub 1, my next term would be the prior term plus the common difference, plus our D value, our common difference. So that's exactly what it's saying right here. So let me just show you like how that would work out. If I needed to know what A sub 5 is, A sub 5, we found A sub 4, we found out that it was 30. You may say, well, I know it's 39. Good. This is mental math. This is how it works algebraically. I will need to see that you know how to do this. So what I see here is A sub 5 is equal to A sub, these are the same in values. The in value is the term number. Term 1, term 2, term 3, term 4. So A sub in, it's a little lower, sub, A sub in. If I'm looking for the fifth one, then over here I need to go, well, A sub 5 minus 1, in is 5. So 5 minus 1 is 4 plus D. Now let's see if that makes sense. The fifth term out here, the fifth term, A sub 5, is going to be A sub 4 plus the common difference. Thumbs up if you understand where we're going with that. Does that make sense? Thumbs up, sideways down for so far? Good. Yeah? Okay. Thank you. So I knew that a sub 5 is going to be a sub 4. We found out was 30. 30. Plus our common difference we said was 9. 39. Okay? So you see how this is kind of like it's extra to write it all out. It is kind of mental math. I'll need you for each problem where you have to do that. At least show this process. One or two times. Okay. Now this, give me a thumbs up, sideways down for this part. N minus 1. Thumbs up, sideways down for n minus 1. Is that a little confusing? Not really? Okay. Okay. So just remember that n is the term we're looking for. So n minus 1 is going to be the term before it. That's all that means. Okay. All right. So that's what we did in our first example here. And now we need to do something a little more complicated. Now we want to find the nth term. So I'm going to look for a sub 23 because that's what I was going to do up here and I told you not to do it. Some people did it, but you'll see how much faster it is here. You don't have to write all those numbers out. Good job on you for doing that though. Look at what we're asked to put in here. Nth term, look for the 23rd term. Perfect. A sub 23. The first term, I know it's first term because it's a sub 1. My a sub 1, 3. So I'm going to put 3 plus my n, which is the number of the term I'm looking for. The number of the term I'm looking for is 23. Minus 1 times the common difference, which we said was 9. Wow. So the 23rd term, I'm going to start to whittle away at this. 3 plus 22 times 9. Three plus 198. So the 23rd term is what? Tell me in the chat when you get it. So we got this far. What's next? All right, there it is. Calvin first. Again, good. Avi, good. Marco, good. Anyone else? All right. So I just had to multiply 22 times 9. So I think 20 times 9 is 180. 2 times 9 is 18. Connect them, 198. Plus 3, 2, 0, 1. Nice. We did it. We did it. All right. So this explicit formula is helpful to find the nth term. It's also possible, right now we're going to create an explicit formula for any term. We're going to have a formula where we just plug in an n value and we're going to get the number automatically. That's kind of what we did, but in what we did here, we used 23, right? In the actual problem we just did, we used 23 and inputted that into the function. Now, if you weren't given the goal to find the 23rd term, you could create this explicit formula, to find any term. That's all I'm saying. So watch, it's going to be based on this exact same problem up here, all the same values, but instead of A23, I'm going to say just A sub n. A sub n. So this is, again, to create a explicit formula for any term, not the 23rd term, which was our question up here. We're just going to create it for any n value. Now watch. Same thing applies. The nth value is what I'm looking for. A sub 1 is 3 plus n minus 1, because I don't know the n value I'm looking for, times 9. Correct. Correct. Jeremy, that's very good insight. You can use the explicit formula to find a recursive next term, right? You can't use the recursive formula to find any nth term. But yes, the explicit formula can be used for everything. You could find what comes next up here using the explicit formula, even though that'd be a waste of time because we could just add it. But I like that insight. You're bringing it together. If you understand that already, good job. A sub n is equal to 3 plus what we got to do with this 9. Distribute it. We'll see another example problem like this, so don't worry if you're not quite putting it together yet. 9n minus 9. And we're almost done here. We're going to combine these two guys. Minus 6. Okay. So if we were using this to find the 23rd term, we would put a sub 23, plug in 23 here, and you'll end up with 100 or 201 as well. 3, 27, 6, yep. It gets you all the way up to 207, and then you minus 6, you get 201. So really, we can use this to find the nth term. We can also use the explicit formula to just, with the scenario given, find the function, or sorry, the equation that we can use for any of these values. So now I could find a sub 50 because I would just need to plug it in as 9 times 50 minus 6. And what is that going to be? 444. Yep. Okay. All right, last one. Go ahead and tell me then, what is a sub, let's go, 135? What is a sub 135? That's super challenge. Remember, we've already created the recursive, explicit formula for this. We've created the explicit formula for this. I should really put this like that. That makes more sense. So right now we're just looking at the explicit formula. Dang it. All right, if you got an answer for a to the 135th, give it to me. How would I do it? I would take this and I would say, okay, well, a to the nth power, we've made this explicit formula, so I can plug in an n value and end up with the 135th term. I can't do that one. 135 times 9. Yeah? I have two different answers from two of my aces. So let's see what we get. Ah, nice. Marco, you got it. There you go. Calvin, you got it. Eliana, you got it. Good job. Anyone else? Okay. So I worked this out. This looks like it works out to be, what is that, 1215? 1209. So we just figured out the 135th term. Now, if you had to go through this like this and make dashes and write 135 terms, it would take you all day. So we're going to use the explicit formula. All right. Next, guys, open up. I didn't have you copy this down because it is in your workbook. It's in your workbook on page 227. I actually even have the page number for you. So open your workbook, guys, 227. 227. 227. Oh man, that was a really cool TV show in the 80s. 227. If your parents are around, ask them if they know what the TV show 227 was. If they know, they're cool. That's definitely not true. I can't make promises. All right. Okay, that's probably enough time to get your workbook open at page 227. We're looking at example 1 in your workbook, so no need to copy it down, or you can just copy down these numbers and find the 10th term, a sub 10. So we need to find what a sub 10 is. First, let's figure out what our common difference is. If we plug in the next exponent right away, these aren't exponents. These are sub values. This is only the 10th term. Good. Somebody told us that our D value is 6. Because look, I'm adding 6 to get here. Add 6, add 6. And what would the 10th term? Let me read that again, Jeremy. One sec. Okay. When I'm explaining it, Jeremy, tell me where you're saying it's a shorter way. Okay. So look, if I need to find the 10th term, find the nth term. We're going to find the 10th term. A sub 10, that's going to be equal to a sub 1. A sub 1, 3. First term, 3. Plus 10 minus 1 times 6. So Jeremy, tell me what the 10th term is. Maybe you were talking about the last problem. Last problem? Okay.
Is it 57?
Is this 7?
57.
Oh, you're saying the answer. Let's see. That's going to be 954 plus 3. Yeah, that's 57. Very good. And while I'm writing that out, what was your quicker way? I'm curious.
Well, the first thing you did, you calculated like the formula for previous, but if we were to plug in the actual value of n, it was 154, if I'm not wrong. We can just subtract 1 from it, then multiply by 9 and add 3. So it's going to be like a bit faster.
What you described is exactly what we did. So you said if we multiply. Wait, you were talking about not this answer question though, were you? Oh, I see. So you said we can plug in the value we're looking for, 10, subtract 1, multiply by 6, and add 3.
Yeah, but I was talking about like the previous one.
Oh, the previous problem. The previous problem is slightly different, because in the previous problem over here, we created the explicit formula, and then we're able to plug in the 135 down here where we were asked to do. Okay. The slight difference. Oh, I see. You're saying that this. Okay, let me think about that. 9.
We could have done what you've done last. We could have done like your first step.
Oh, I see. That man, if this was in the classroom, I would just say, "Show me your work and where." But we're kind of like playing telephone, trying to figure out this part. So I'm going to continue to teach it the way I am going to teach it. It sounds like you have a mental math shortcut. There are some additional steps I'm teaching because I'm teaching to everybody. Okay, so good job in seeing other ways to do it. I'm going to keep going with this method. All right, a sub 10, and then we get 57. All right. Thumbs up, sideways down. How do you guys feel about it after seeing the first few example problems? Pretty good? Yeah? All right, let's keep going. No problem, Jeremy. I like to hear input from students. If it just takes me too long to get everything you're saying, I have to move on. But if this was the classroom, again, when there was a down point, I would go over and talk to you about it. So sorry. I appreciate your input, always. Let's look at this. Next, this is example 2 on 227. write the explicit formula for the nth term. So this is going to be the situation that we did where we don't have a term we're looking for as if we had the 10th term. We don't have the 10th, we don't have a goal of like a 10th term. We only have the goal to create a formula that will work for all of this. Okay. So what is our d value? What's our common difference with this? How do you go from 8 to 1? How do you go from 1 to -6? It's like you're on a diving board a foot above the pool, and then you go down 6, or you go down a certain number of feet to get to -6. So we go down 7 feet from the diving board to get underwater 6 feet. 8 to 1 is also -7, so we know our d value now. We'll also need our a sub 1. A sub 1. All right, perfect. It's 8. So let's just go for it then. A sub n, I'm going to write it out first so we can look at it together. N minus 1 times d. Okay. So we don't have a target of a specific term. We're just writing the explicit formula. So watch. I'm going to keep a sub n because I could look for any term after I finish this. Let's see. A sub 1 is 8 plus n minus 1 times -7. All right, watch your positive negatives here. Watch your positive negatives. A sub n is equal to 8. We have to distribute this. -7 times positive n is -7n. -7 times -1 is +7. Combine what you can. Let's combine these. -7n plus 15. Whew. Yep, you got it. Excellent. Excellent. All right. What did I have on this side? All right. This is number 3 in your workbook. It's number 3 on page 227. A sub 1 is 20 to 29. Find the first 5 terms given the recursive formula. A sub n is equal to a n minus 1 plus 5. This is basically just the mental math, and it tells you, I put this here to tell you what the common difference is. So all we need to do is fill in the first 5 terms. And what do I know as my first term? A sub 1 is 29. So we know our common difference. Let's go ahead and fill them in. You don't have to do much formula work. Maybe do it for the first one. A sub 2 is equal to a sub 1 plus 5. A sub 2 is equal to 29 plus 5. 34. 34. Keep going. Give me your answers in the chat when you're done. I see. One thing we know is the common difference is plus 5. So after we do the recursive for one of them, I think we're ready to see that. We can just add 5. Nice, Cam. There you go. Yes. Just remind me about the screenshot. All right, 34 plus 5. We're going to get 39. Plus another 5, 44. Plus another 5, 49. Okay. Are these going to be hard problems if you have to do that? It's not so bad, right? Nah, it's not so bad. All right, the last problem we have. Yeah. Well, one sec. Don't look at that. Literally cut and paste. All right. So, given. Well, actually, move that down. There you go. Now we got to write an explicit formula for that sequence up here. Okay. So remember our explicit formula? A sub n, a sub 1 plus n minus 1 times d. We already know d is 5. We already know a sub 1. We were told it's 29. So go ahead and make a recursive formula for me with that. The hardest part is distributing this d. Put in what I know. 29 plus n minus 1 times 5. And distribute. There it is. Right. 5n minus 5. $24 plus 5n, but I like it much better like this because actually now it's a linear function. And if you were to draw this linear function, all the values that we got would be y values on our function. So that's kind of like the bigger idea is that the explicit formula is actually for these problems, they're linear. Good, Kimberly. All right. Okay. All right, guys. Give me a thumbs up, sideways down for the lesson. How we feeling? Feeling good? Ooh, had a yawn while I was talking. Thumbs up. Awesome. Love to see that. Good. All right, we got looks like unanimous thumbs up from people who are giving me thumbs. So I'm gonna go ahead and flip this over. Or actually, who wanted this? Haley, do you need to have this as well? Screenshot, and then I'll turn the paper. Okay. And then like this, I guess. There we go. I think it gets everything. Screenshot. And no, I there's a couple on the homework that are going to be a little challenging, but I think you can do it. All right, that concludes our class, guys. Thanks for sticking in there. Oh, let me stop this recording.